for joining us today. My name is Karen Papazian, and I'm a PhD student at the University of Miami's Rosenstiel School of Marine and Atmospheric Science. I study atmospheric science. Today, we will hear from my colleagues Mary Beth Arcodia and Rebecca Evans. They will teach you about important impacts of climate change, especially how Miami is feeling the impacts. And then they will dive into how climate change is impacting hurricane hazards. To start things off, I'll pass it on to Mary Beth.
My name is Mary Beth Arcodia. I'm a fifth-year PhD student at the Rosenstiel School of Marine and Atmospheric Science with the University of Miami. I study atmospheric science, and today I'm going to be talking to you about climate change and sea level rise and why it's particularly important in South Florida. How the greenhouse effect works is the sun emits short-wave radiation. It has so much energy that it moves straight through our atmosphere and reaches Earth's surface. The Earth then re-emits this energy back out to space. But because the Earth has less energy, the radiation is now long-wave radiation, and some of this gets trapped in our atmosphere due to greenhouse gases or water vapor, methane, carbon dioxide. These gases trap that long-wave radiation, which is why we call them greenhouse gases, and they cause the atmosphere to act like a blanket over the Earth, and this is what causes global warming. Now that we understand how global climate change works, we can understand how climate change affects sea level rise. So here we have a few experiments set up to show how the warming of the Earth causes the sea level to rise. The warming of the Earth is causing the sea level to rise for two main reasons. One is thermal expansion, and the second is ice melting. So first, to show thermal expansion. Thermal expansion means that when something gets warmer, it expands. And so here I have a balloon, and here we have liquid nitrogen, which is very cold. And so we moved some of this liquid nitrogen into this cup. Now I'm going to take the balloon and put it into a cup filled with liquid nitrogen. The balloon gets very small because the air inside of it is contracting, because as things get colder, they get smaller. So the air inside of this balloon is getting much smaller. Then you can see it's much smaller. When I take the balloon out of the liquid nitrogen, the balloon starts to expand because the air inside the balloon is expanding. The same thing happens with our ocean. As the ocean is getting warmer, it's quite literally expanding, causing the sea level to rise. The second main reason that climate change or global warming is causing the sea level to rise is because of land ice melting. So here we have a cup of water, and I'm going to mark on this cup where the water line is. So you can see here we have the line of water. Now, if I take ice and put it into this cup, we can see the water level has now risen because I take ice from outside of the cup, put it into the cup, and the water level rises. Now we can see that as the Earth is getting warmer, it is causing the sea level to rise for two main reasons. One, thermal expansion. As the ocean is getting warmer, it's expanding, causing the sea level rise. And the second is when ice is melting from our glaciers off the land into the ocean, it's causing the level of the sea to rise. Just as if you had a cup of water and added ice to your drink, it would cause the level to go up. Sea level rise is not uniform across the globe. Here is a map of the globe, and we can see that sea level rise is much higher in some areas and lower in others. Unfortunately for us in South Florida, the rate of sea level rise is much higher than it is in the rest of the world. Sea level rise is a big concern for us, especially here in South Florida. We are a very low-lying state, and so sea level rise can cause our fresh water to get intruded on by salt water, and it also causes major flooding. Sometimes we see flooding events even when it's not raining. Another main reason that sea level rise is an issue is because of the hurricanes that we get here in South Florida. A higher sea level causes worse storm surge.
Here we have a makeshift beach setup. Here are people on shore, and here's our ocean. Now, if a hurricane were to come across, it brings massive winds and it blows this water onto land. So it's taking our ocean water and pushing it onto the shore, and we can see our people here are getting wet. Storm surge is a major threat from hurricanes, and a higher sea level can cause worse storm surge.
While climate change and sea level rise are global issues, there are things that you can do at home to help stop the rate of sea level rise. And a big one is just by reducing the amount of plastic you use. Plastic waste often ends up in the ocean, which can harm our coral reefs and our mangroves, both of which are helping to keep the sea level where it should be. Also, plastic production companies and distribution companies are often contributors of those greenhouse gases, especially carbon dioxide, which is making climate change worse. So there's a lot of things that you can do. Use a reusable water bottle. Bring your own utensils to work instead of using plastic utensils. Use a reusable straw. Remember to reduce, reuse, recycle. Take public transportation instead of driving your car. Turn off the lights when you leave a room. There's all little things that you can do to make a big difference.
Thank you, Mary Beth, for showing us experiments that can help us wrap our minds around sea level rise. Additionally, thank you for giving us some tips on how we can slow the rate of sea level rise. Now I'll pass things off to Rebecca, who will discuss hurricane hazards and how they are impacted by climate change.
Hi everyone, my name is Rebecca Evans and I'm doing my PhD in hurricane physics now. I am in the computer modeling of hurricanes research group and I study specifically how hurricanes are affected by the rising and setting of the sun. Today I'm going to be talking to you about hurricanes are affected by climate change, how they've been affected a little bit already, and how they're expected to change in the future because of climate change. And specifically, we're going to talk about how climate change is expected to affect the hazards of hurricanes. So that's the wind, rain, and storm surge. So first, we're going to do a little overview of what a hurricane needs to be able to form in the first place. And the reason that we're going to do that is we're going to talk about what it needs to form, how hurricanes will be expected to change in the future, and what that means for the hurricane hazards. So the first thing that a hurricane needs to be able to form is a warm ocean. And the reason for that is that the ocean is the fuel for a hurricane. So the warmer the ocean is, the more fuel there is, and if it's warm enough, then a hurricane might be able to form. So we need a deep layer of warm ocean so that there's a big heat supply into a hurricane, and thus it is more likely to be able to form. The second thing that we need is a humid atmosphere, and what that means is that there's enough moisture in the atmosphere for clouds to be able to form. And the reason that we need that is we need clouds to form so that they can aggregate into hurricanes. And the third thing that we need is favorable winds. And what that means is that the wind at the bottom of a hurricane and the wind at the top are roughly the same. And the reason that that is a good thing is that once clouds form and start to aggregate, if the winds at the top and the bottom are about the same, then the clouds don't get ripped apart before they form into a hurricane. So we need these three things together: a warm ocean, a humid atmosphere, and favorable winds, so that we have a heat source, a moisture source, and the hurricane doesn't get torn apart before it has a chance to intensify. So with these three things together, then we have hurricanes. So each of these things are expected to change in the future, and one of the hazards that we expect to change is rain. So to explain how rain is expected to change, I'm going to use an example of Hurricane Harvey. Hurricane Harvey happened a few years ago, and you may remember that it dumped a huge amount of rain on the Houston area. And there was a good reason for that, and it was because it essentially stopped right around the Texas coast. It just hovered around the Texas coastlines for several days. And what that meant is that it was able to access the moisture supply from the Gulf of Mexico. So the Gulf of Mexico, there's a lot of water vapor evaporating from the ocean surface. And because the hurricane essentially was at a standstill, all of that water vapor was getting dragged over land and then dumped as rain onto the Houston area. And as you can see in this graphic, there are some areas of Houston that had more than 30 inches of rain, but there were also individual rain gauges that measured 60 inches of rain. So that's 5 feet of rain. That is a lot of rain to happen in a couple of days. These kind of events, like Hurricane Harvey, are something that we can expect to see more of in the future, and there's 2 reasons for that. The first is that we expect hurricanes to slow down when they're moving forwards. So not the wind speeds are expected to slow down, they're actually expected to increase, as we'll talk about in a minute, but the forward motion of the hurricane, like, how fast it approaches the coast, is expected to change. It's expected to slow down. So in the future, we have more hurricanes that are more likely to stall near coastlines or just stall in general, and what that means is that they can drop more rain onto an individual place. The second reason that we can expect rain to increase with climate change is that a warmer atmosphere can hold more water vapor, and this is just a property of air, that the warmer it is, the more water vapor it can hold, and therefore the more rain is likely to result from that. So that if there's more water in the air and that all drops out of the air, then we're going to have more rain. So with climate change, we can expect more rain from hurricanes. The second thing is wind. So these 2 hurricanes that I'm just going to use as an example are Hurricane Floyd on the left in 1999 and Hurricane Andrew on the right in 1992. And the reason that we're showing you this is that both of these hurricanes were about the same intensity at the time that these images were taken. They were both around Category 5. And you can see that one is a lot bigger than the other. Floyd is much bigger than Andrew. So something that we need to be aware of is the wind and also the size of the wind field. So you can see with Floyd that the wind field, the hurricane itself is much larger, and that indicates that the wind field is a lot larger, and so the damage extends over a larger area. Whereas for Hurricane Andrew, luckily because it was small, the damage was limited to a slightly smaller area, even though the winds were very strong. So with both of these examples, they were around Category 5, which is a major hurricane. Anything above Category 3 is a major hurricane. And we can expect to have more events like these 2 in the future. And the reason for that is that with a warmer ocean, you have more energy going into the hurricane, and therefore you have stronger hurricanes. So you have more heat that's being pumped into the storm, and with that, the hurricanes get stronger. Although luckily, on the wind front, I actually have some good news. Even though we will have stronger hurricanes, we don't expect them to become any more frequent. So we'll have about the same number every year, but the tropical storm and Category 1 hurricanes are expected to decrease in frequency. The Category 2 and 3 hurricanes are expected to decrease in frequency, whereas the Category 4 and 5 hurricanes are expected to increase in frequency. So what that means overall is that hurricanes will not get more frequent, but the ones that do form will be stronger. And that comes from several different studies, but as an example, we've shown you this one from Bender and Co. in 2010. The last thing that we're going to talk about for hazards is storm surge. And what storm surge is whenever wind blows water onto land. And so it seems, intuitively obvious that with sea level rise, storm surge will become worse. So this is an example of what the coastline of the United States would look like if all of the ice in the world melted. Now, this is obviously a very much worst case scenario. This is not something that we expect to happen anytime soon. This is like hundreds of years away, if it even happens at all. But as you can see, if the baseline sea level is higher, then flooding is definitely going to be worse in low-lying coastal areas. And you can see that the low-lying coastal area of the entirety of Florida is not really going to be present in several hundred years if the ice melt continues as it does, but maybe in several decades, if you live in Kendall, the beach will come to you. But so with sea level rise, because of a warming ocean as well as ice melt, we expect that storm surge will definitely become worse. So I'm going to go over everything that we've talked about in a little schematic summary of sorts. So let's imagine what theoretically is going to happen to that hurricane and what it means for each individual hazard. So here's our little hurricane sitting out in the middle of the Atlantic. and the winds are counterclockwise like this. This is in the northern hemisphere. So in the future, we expect the ocean to warm, as represented by this red ocean that we have here. And so as the ocean is warming, it's just pumping all this heat, all this extra heat into the hurricane, the heat that isn't really as readily available today because the ocean is cooler today than it will be in, say, 100 years. So all this heat is being pumped into the hurricane, and therefore the winds are stronger. So all this extra heat means stronger hurricane. And then let's imagine some part of the atmosphere. And the atmosphere is going to warm up too. So the atmosphere as it is at the moment can hold X amount of water vapor and thus produces X amount of rain. In the future, with it warming up, we expect it to be able to hold much more water vapor, and therefore it will be able to produce much more rain. So increased ocean heat pumps more energy into the hurricane, giving us stronger winds. Increased atmospheric heat means that more water vapor can be held in the air, and that produces more rain. And a higher sea level means more chances for flooding and therefore worse storm surge.
We'd like to thank you for tuning into our discussion of climate change and hurricanes. While we can see the impacts of climate change in Miami today, Miami isn't the only place experiencing these impacts. So I'm here on Long Island in New York, and we too experience impacts from climate change. Climate change really is a global issue. So now we'd like to leave you with some discussion questions to keep the conversation going. So first, have you seen sea level rise happening where you live? Do you ever see flooding without it having rained? And what would you consider this a sign of? What are some things that you can do to help slow the rise of sea level? And have you already been doing some of these? Have any of these hurricane hazards directly impacted you? And have they indirectly impacted you?